Okay, so welcome back. So now in this example, we're going to look at using method of partial fractions with something that is not a rational or a rational function. Okay, so in this case we have trigonometric functions. So we've got a rational expression involving trig functions. And so how do we deal with these? So in this case here, we're going to use a u substitution. We're going to make it look like a rational expression by letting u equal sine. And then du equals cosine x dx, which works out. And so we're going to write this as du over u squared minus u. And so now this equals du over u times u minus 1. And again, if we use the partial fractions decomposition, well, what do we get? Well, let's do our scratch work here. Oh, so this is going to equal, let's split this up. So this should equal a over u plus b over u minus 1 du. Okay, and so now, what do we know? Well, let's do our scratch work. And so we know that it has to equal 1, so we have 1 equals a times u minus 1 plus bu. And so now, if u is 0, excuse me, so if u is 0, what do we get? We get 1 equals negative a, which means a equals negative 1. All right, so we got this one. Okay, let's do the next one. What if u is 1? We get 1 equals b. And we're done with that one. So b is 1. All right, so guess what? Now we can integrate. And this becomes, we're integrating. So this becomes the negative natural log of the absolute value of u plus the natural log of the absolute value of u minus 1 plus c. But now we plug back into what u is. And so we get our final answer, which is negative natural log of the absolute value of sine x plus the natural log of the absolute value of sine x minus 1 plus c. And that's your final answer. So here's one for you guys. Again, see if you can do this one. If you get stuck, let me know. Or if you just want confirmation that you did it right, let me know. So then this is going to be the integral of x plus 1 over x plus 3 times x minus 2. So go ahead and do this one. And again, use partial fractions decomposition, whether you use the equation method and solve for a and b algebraically, or whether you use the strategic substitution method. You should get the same answer. Just make sure you set it up correctly, set up the equation correctly, set up the partial fractions correctly with the constants, and you should get the correct answers. But again, always make sure that you set it up correctly. Okay, take care.